Good evening, everyone. So today we are going to cover remote data types in Python. Right, those are some crucial data types. We are going to cover list, tuple, and dictionary. Okay. Okay. So we have seen some questions, right? We have seen some. I think I have provided you a question for homework. What is the technical term for casting an integer to a float? And what is a term for casting a float to an integer? Right. Any answers for this? So the technical term for this is upcasting and downcasting. Okay, casting an integer to a float. This is known as downcasting. Okay, and casting an integer to a float is downcasting, and casting a float to an integer. It is downcasting. Okay. 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 So casting an integer to a float, that is upcasting, and casting an float to an integer, that is downcasting. Okay, nothing more with these terms, right? So we have seen how Python manages memory, right? How Python saves memory. It will assign the same memory location to the variables with same values, right? Again, one more thing. See, Python is a dynamically typed language. Okay, Python is a dynamically typed language. What it means that, see, in other programming languages like in C++ or Java, those are static typed, right? What happened that you have to define the data type of a variable, and that variable can only store that type of data. For example, if I will uh, I will define the data type of a as integer, right? This is the syntax of defining a data type of a variable in Python with using columns. So if I will define a data type of a variable in other languages, suppose in this case a is defined as int, so a can only hold the values of an integer in other languages, right? But in Python, a can also hold value of a string. It can also hold a float value. It can also hold a boolean value, right? So Python, JavaScript, these are dynamically typed language. Okay. The data type of a variable is defined by what type of data that variable is storing, right? You cannot explicitly define it. So you cannot explicitly define what is the data type of a variable in Python, right? If you store an integer value, then the data type of that variable is an integer. If you store a string value, the data type of that variable is a string. Float value, then float, boolean value, then boolean, right? And all these four variables, all are single variable a. We are just changing the value of that variable a. Okay, let me give you a presentation for this. This was our code. See, our interpreter just started the execution, right? So the first line is A is defined as an integer. This is our memory area, right? This is how memory is created in your RAM. Okay. See, once the A was defined, once the A was defined, we have a A. Okay, just leave this annotation right now. We have a variable named A, and that variable is linked with an integer value 10, right? Now, then again we have the same variable A, but now what happens? It is now pointing to a string. It is now attached to a string, right? The linking with that integer is deleted, right? It is now attached to a string. Okay. Now we will create a float value. We will provide a float value to that variable A. What happens? Now it is attached to a float. That string was deleted, right? This, there is the only the same variable A. Okay. Then again, A is attached to a boolean value, and that string was deleted. That float was deleted, right? And the our code ends. Okay. So this is the power of Python. It is dynamically typed. The type of a variable is defined during runtime. Okay. The type of the variable is defined during runtime. What type of value that variable is storing. Okay. So this syntax, okay, using colon to define the data type, it is not bounded that A can store an integer. I can provide a float value right here, right? And if I will run, the first type is float. So this integer is only for there for documentation, right? Whenever you are writing a code, it is a very good practice to provide a good documentation, right? And there is no other use for that particular variable declaration. Okay. Now let's talk about list. So how to create a list? This will create an integer. How to create a list? So to create a list, there are two syntax. First one and the second one. Both of these will create an empty list, right? An empty list, a list without any value. Okay. Now, what is a list? See, suppose this is a box of an integer, right? This is the box of a string. So string will take much more space. Okay. This is the box of a float. Okay. This is the box of a another end, right? Now, all of these combined together, all of these combined together are linked by, suppose we have our lookup table and we have a list here. Suppose the name of the list is L. So this is a list. A list can contain multiple values of multiple data type. In case of an integer, suppose if I will create a, in case of an integer, what happens? We will only get one single block of memory, and this A is linked to this memory block, right? But in case of a list, what happens? We get multiple blocks of memory, right? As much we want, right? And different values are stored inside these blocks. Suppose in A, in an integer, 10 was stored. In list, you can store a 10. After this 10, you can store, suppose, a character, a string A. After this, you store some other value. After this, you store some other value. So this is a list. List can contain multiple elements of multiple different data types, right? Okay, so let's see an example. So this is how you will create a particular empty list. Okay. Okay. So suppose I will create a list with some values. how Python is able to create such type of list with different data types, right? It is when if you go into the implementation of this particular the memory implementation for a list, it is a tricky one, right? It is not easy to provide such type of compatibility, right? To store different types of data with the same variable inside the same list, right? So let's see how that is done. Uh, the first thing first, the diagram which I have just drawn was not entirely correct. Okay, the size of each block inside a list is same, is equal. Okay, let's take how many units we have. Five. And now we have a list L. This is pointing to this particular memory location. Okay, now first element one. So how this one is stored? There is some another memory block for that one was created, right? And the your interpreter Python interpreter will keep that one inside this memory block. Okay, and see, we have discussed about the memory location, right? The memory location of this one will be stored here. Okay, then again we have other value that is 2. A new memory location will be created for that 2. Value 2 will be assigned to this memory location, and the address of this memory location is stored inside your list. Right? After this, we have a string. The memory location of the string is stored. After this, we have a float. Memory location of this float will be stored. And after this, we have a boolean. Boolean is always of 1 bit. And the memory location of that boolean is stored here. So deep down, if you will observe that this particular list it is only storing the memory location of the values, right? This one is not entirely inside your list. Your list contains the memory location of that one. Your list contains the memory location of this two. Okay, let me give you a visualization of this. Suppose I have a list values, and see, this is how the list will be created. This is the memory location of your list. Your list variable will be linked to this memory location. Each and every data type will get their separate memory location, and their memory will be stored inside your list, right? This is how a list is created in Python. Okay, now let's see how we can access these values. Suppose I want to access this two. Okay, so what is list? List is collection of multiple values of multiple more than one data type, right? Suppose I want to access this two. How to do that? So for that, suppose I want to print my whole list. We will do this. Just use the print statement and it will print the list, right? I want only to print this two, right? For that, there is some concept known as indexing, right? Index. Now, what is index? See, let me get this clear. What is this? A memory block, right? So if it is a memory block, it should have a memory address. Again, this two will be having some memory address. Again, this string will be having some memory address. Similarly, what is this? This is again a block of memory. Okay, and it should have a memory address assigned to this. Right? Again for this block, again for this block. right? But we cannot, you can say, use these memory addresses in our code, right? It is not very easy to remember these memory addresses, right? We have seen that it is a hexadecimal large values, right? So instead of memory addresses, to access a single block, in a list, we have something known as indexing. And what is this index? So index always start with 0. This first block, yeah, this first block, this will get the index 0. Second block will get the index 1. Third block 2, fourth 3, fifth 4. Always remember, indexing always start with 0, right? Suppose now, so what I want to print this 2, right? So what we have as indexing 0, 1, 2, 3, 4, right? Now what I want to print, that 2, right? Inside square brackets, use the index of that particular value. We will get that value, right? This is how you can access a particular separate element from a list. Suppose I want to print this string. I want to print this string. Okay. So using index 2, I can print that string. Now how? See, if I will print the type of my list 4, any guess what will be the output if I will print the type of my list 4? So the output will be Boolean value, right? Because in index 4, we have a Boolean value. See, in index 4, we have a Boolean value, right? Index 4, okay? So we have a Boolean value. What will be the output of 2, index 2, data type of index 2? So the data type of index 2 will be string, right? So this is how a list is created in Python. This is how we can access a single element of a list, right? Now see, this indexing a particular string, so a string also supports indexing, right? For this H index 0, E index 1, L index 2, this, right? So if I will print my string 10, I will get the answer D, the output as D. Okay. If I will print my string 3, I will get the output as L. If I will print my string, I will get the whole string as my output. Okay. Now we have seen that. Okay. Now see, this is a string, right? Now inside this list, I want to access this string, and not the whole string. I want to access this A, exactly this A in the string. Okay, I want to access this A, exactly that A. How to do that? How to access an index inside a list, right? So my list. Okay. So what is this my list 2? It is nothing but our string, right? We are getting our string. So suppose this my list 2 is our string, right? So let's take a copy. This is our string. I will print my string, get output as my string, the string we have, right? If I want to print this exactly this A and I will pass indexing as 1, we will get the output as A only, right? Okay. So we will get the output as A only. But there is no need to create a separate variable to achieve this output, right? So now what we are trying to do, we are trying to access the string, right? What this is giving us the string, right? Inside that string, what we are trying to do, we are trying to access index 1, right? And if I will run this, then again we will get the same output. What this is trying to do, this is giving us our string, and this particular indexing, it will give us the exact, that particular exact character of the string, right? So these are something like operations, or you can say indexing, how to access a particular value in list, right? So let's take the same example. Any guess what will be the output of this particular print statement? See, it will be 5.98. That will be the sum of index 1 and index 3, the values of index 1 and the values of index 3, right? Our index 1 is storing an integer, not a string, and we cannot add a string and an integer. Suppose I want to create a variable a, and the value of variable a should be abcd plus 4. This will give me an error, right? We cannot create, we cannot add a string and an integer. It is not allowed, right? So if I'm adding a particular value here, it should be of numerical type, right? Or of same data type, right? Yeah. Okay. So guys, any questions till now about indexing and how to create a list? Okay. So suppose I have a list, and before this, let's create a value 10. Let's create a string body. Let's just increase 1, 2, 3, string. Suppose I have them list values. Okay. So just give me a statement, right? Give me a print statement to print this 300. I only want this 300 as my output. Yeah, there is something, there is a concept of negative indexing also. We will see that. Right. First, give me the output. Give me the particular print syntax to print this 300. I only want this 300 as my output. Also, I want to print this hello world as my output. Okay, hello world as my output. I also want to print this L, only this particular L as my output. Right? See, don't use this temp list, use this my list. Okay, use this my list to provide the output, right? To get the output. Suppose these variables are not there, right? To use, you can only use my list. Okay. For indexing, we always use square brackets. Okay. Okay. So first of all, let's see how this my list is looking. This is our list. Instead of just inserting values like this, I have inserted variables. That is also same. There is no difference. Okay. My list 7 2. Yeah, that will be correct. See, so what is our target? What we want to print? We want to print this 300, right? And this 300 is inside our temp list. First of all, we have to access this temp list, right? The index of that temp list will be 7. So let's first index that temp list. Now we are inside temp list. We want the index to, so let's use, first of all, let's only print this one. What we will get, the all the values of temp list, right? Now, if I will give index 2, I will get the values 300, right? Now guys, remember this implementation. Your list is only holding the memory location of the values. Now let's see how this is looking. Okay, see, we have created a, we have created a my string, we have created a temporary list, right? After this, we will create a my list and see how this my list is looking, what it is doing, right? So we have provided the raw values 1 and 2. This 1 and 2 integer values are provided inside my list. So my list will create a integer 1 and a value of integer 2, right? Okay. Now, what was the my list 4 9? Yeah, that will print the L. That one is correct. 4 9. Okay, see. So 1 and 2 is provided in our list, right? What is this A? We are giving a variable A, right? See, variable A and that location index 2 will point to the same memory location, right? So what is a list? List only contains the memory location of the values. Okay, so it is pointing to the same memory. with value 10. Now, third we have true. So it will create its own boolean value true. Now after that we have my string. Right after this we have my string. Okay. So after this we have my string. So my string is pointing to a string. Your list will be again pointing to the same string. Exactly same string. Right. Okay. Minus 98 minus 1 will be provided to the list. So the list will create its own memory for that. Then we provide a temp list. See, temp list is pointing to a list. Again, my list is pointing to the same list. It is known as nested list, right? So it is known as nested list. Okay. So suppose if I will create a list, values 1, 2, 3, 4, right? And inside this, if I have one some another list with A, with B, with C, right? So this one is known as nested list. Instead of creating a list like this, I have provided a list variable only. Right? Both are same. So please try to understand this memory mapping because there are some problems we are just going to face, right? Yes, lists are mutable. We can change the values of list. Overs of a string. Where is string? See here. We have got under method that is reversed. Okay. Yes, am I audible? I'm getting a network lag. It's good. Okay. So there is we will see this the example of printing a string in reverse. Right. Let's first discuss about these things. Right. Let's finish the list. So suppose, see, notice one thing. This my string and this particular index 4. Okay. Both are sharing the same memory location. Right. So there you can say that there are some consequences of sharing the same memory location. Right. See, as lists are mutable. Okay. Lists are mutable. Suppose I want to change this value 1. Okay, I want to change this value 1 to something like 100. I can do that. My list index 0, 100. Okay, and it is fine. There will be no error. Okay, and if you want to check that the ID of list, my list, see the ID of my list is exactly same. There is no change in memory location. So we can conclude that list is mutable. Okay. Now, if you want the visualization, so let's take this one, remove these model functions. If you want to change my list index 0 to something more than 100, right? So let's check. See, first we have the value as 1. So integer in itself is not mutable, right? We cannot change this 1 to 100, right? But list is mutable. So what it will do, see, we will create a new 100, right? And your list variable, there is no change in the list, right? So we can, there is no change in the memory of the list, right? So list is mutable. So now it is pointing to the 100. Now see how Python manages memory. There is some 100 value, 100 integer, right? So your list is now pointing to that 100 integer, right? So instead of 100, let's do 1000. Don't create any confusion. See, now the first value is 1, but after the change, a new integer value 100 is created, but there will be no change in the memory location of the list. Okay. Now, so we have this, right? Now, there are some consequences of using shared memory. What happen if I will change? If I will change the value of my string, right? And if I will try to print my list, any guess what will be the output? What will be the change in the output? What will be the change in the output? Just take a guess. Okay. See, your list is holding to some memory location with some value, hello world, your string. Your list is again pointing to the same memory location. If I will change the value of this hello world to some other string, let's see what we will get. The value the value of your list won't change, right? See, we will see the representation. A my string temp list, the list. Now see, your list, it is pointing to a memory location, right? It is pointing to the memory location, not to the string, pointing to a memory location. What we are trying to do here, we are trying to change the string, right? See what happens. Your string will be allocated a new memory with a new string, that is ours, right? But your list will remain pointing to that string memory, right? So there will be no change in the list. Okay. But according to our logic, suppose there is a scenario, you want to store a string, it will change with time, right? A variable will change and that will change with time, right? So that is not possible like this. Suppose so the string won't change, right? Changing during runtime, a string can change inside a list during runtime. That is not possible like this. We have to use dynamic memory allocation for that. Right? That is some different concept. Okay. For right now, just understand that it is pointing to the memory location, not to this string. Okay. Now let's remove all these. Let's focus here. Right? So we have 0, 1. So it will print the nested list, right? But what happens if I will try to update the value of temp 0 from 100 to something like a string? Right? Now what happen if I will print my list? So let me execute this one for you. We get a better look. See, this is the memory representation, right? And we are trying to change this 100. Right? We are trying to change the value of this index 0, right? So does the change will reflect in my list or not? Just yes or no. Take a guess, right? See, guys, okay, there will be a change. See, this, okay, so at index 2, what we have, does index 2 is pointing to this 100 or index 2 is pointing to this temporary list? Index 2 is pointing to that list, right? So any change inside this list will be reflected to index 2. Any change inside this list will be reflected inside my list. See, the value of 100 is changed to hers. Okay, let me give you example here. So this was our example, right? Let's remove this. See, see, our list is not pointing to my string, right? It is pointing directly to a memory location. Okay. So any change inside this memory location, any change inside this string, exactly inside this string, exactly inside this hello world, any change inside this hello world will be reflected in our list. Why? Because our list is pointing to that memory location. Okay. After this, we just change the string value. That's it. Right? We change the string value, not the list value. Okay. So strings are immutable in Python. So there will be no change here, right? So I cannot give you an example of that. But right now, what we are dealing with, so lists are mutable. Okay. So we can change the value here, right? Inside this temp, I can change the value. Okay. So see, how come we will get the output like that? Suppose what is index is 0, let's take some string C. Okay, right now this index 2 is pointing to a list. Okay, and the values of this list can change. List is mutable, so the values of this list can change. Right now, what happened? I will create a hello, a string hello for this index 0. Right now, again, the index 2 of my list is pointing to this whole list, right? If I will try to print this whole list, I will get the string. Okay, so that's why this my list is not pointing to this 100 or 200. This my list is pointing to this 10. Any change in this 10 will be reflected to my list. So, are you guys able to understand this one? Because this is, you can say, a hard topic to understand. Any question here right now? Because after this, we are going to again see a very crucial problem. Okay. So see, this is a problem, right? A change in one list is reflected in another list. This is a problem in Python. Okay. So how to handle these situations, right? Again, we have one more problem with same type of memory allocation. Suppose I created a list 12, 13, 14. Let's only take this time only takes integers, right? And I will create a my list 2, and let's give it equal to my. Okay, first of all, let's see the example with an integer. A is equal to 10, B is equal to A. If I will print the ID of A and the ID of B, will the output be same? The memory location for both A and B will be same? Yes or no? Yes, so memory location will be same. Now see, I have changed the value of A from 10 to 12, right? So let's see what happens. Okay, just first of all, just take a guess. What will be the output of A and B? Both 12 or both 10? What will be the output? 10, 12 or 12, 10 or both 10, both 12? Yeah, 12, 10. Correct. See, okay, first of all, let's check the output. 12 and 10 is our output, right? Now, see, A was created, B was created, both are pointing to the same integer location. Now, A and B are pointing directly to the value, not to some other memory location, then to value, right? What we have seen in a nested list. In nested list, what my list was pointing to, it is pointing to temp. Then that temp is pointing to 100, 200, and 300. But in this case, A and B both are directly pointing to an integer memory location, integer value. Print the IDs, both will be same. Now what I will do, I will update the value of A to 12. So the value of A will be updated to 12, no problem. And we will get the outputs, right? But in this case, say when dealing with list, because lists are mutable, so see how the memories were allocated. See, my list, so a list was created, different values were created, and the address of those values were stored inside your list, right? This is how a list was created in Python. Now we will create a my list 2. This my list 2 is not going to point to your values, it is going to point to your list. So tell me, if I will change any value inside this my list, will it be reflected to my list 2? A change in the value of my list is reflected to my list 2? Yes or no? Yeah, that will be correct. Any change in my list, if I will change the, suppose I will change the value of my list to 0 from 12 to 100, and if I will print, okay, print here, make sure that the two lists were created. Now what I am trying to do, I'm trying to change this 12 to 100. So it is changed to 100, but the output, the change will be reflected in both my list and my list 2, right? So this is again a problem, a change in a single list. was reflected in both lists. Right? So a change in any list. So in this example, I have used my list 2 for the change. In this case, I am using my list to change the value, right? So how to handle this, right? Because it is not a good thing that you will. So, okay, one more thing. When we were using integer values, what we have just done right now, we have copied the value of A to B. We have copied the value of A to B, right? Now B will be equal to 10. Okay. Now, after few hundred lines of code, there is a scenario where you are changing the value of A to 12, right? So it is allowed with integer values. We won't see any problem with that. Right? But suppose I want to copy each and every element of my list inside my list too. And after few hundred lines of code, I there is a scenario where I have to change the elements of my list. In that case, that change will be reflected to my list too again, right? So in these scenarios, the use of function, a special function which is made for list, right? So those are known as list methods. Okay. We have the first one we are going to say is copy. After that, we have append. We have pop. We have clear. First, sort. These are some methods, right? Okay. So let's see how copy works. This is the syntax to use copy. Right. Now let's see how copy works. Okay, so see the change here, right? Delete, yeah, delete is used typically used for dictionary, right? In this case, in case of list, we can use delete, but let's stick to pop and clear. Yeah. So okay, so observe in this case, what happens that Python will be responsible for creating a new memory for 12. Right? Python will be responsible for creating a new memory for 12. Why? Because int is immutable. Right? Python will create a new memory for 12 because int is immutable. Now, so using this dot copy, we are telling Python to create a separate memory location for mylist 2 to the execution. See, a separate memory location for mylist 2 was created. Okay. And if I will change the integer value 12 to 200 in my list, it will not be reflected inside my list 2. Okay. So, so to overcome this scenario, we will use dot copy. Right? Okay, guys. So are you guys clear with the concept of dot copy and how memory, the mutability affects the memory management? Okay. So the same thing, this same memory concept and the conflict with the change in memory or the updation, the reflection of updation in other fields, all these things will be continued to dictionary, tuple, set, queue, double-ended queue, all those data structures we have in Python, right? So it will be reflected in all these data structures. Right? So it is very crucial to understand this one right here, right? Because list is a very simple data structure to understand the memory management. Okay. We have seen copy, right? So what is the role of copy? So the syntax will be list variable, list variable dot copy. Now, if you are talking about copy, let's discuss one more thing. This copy method, this copy method is known as shallow copy. Right? There is one more concept of deep copy in Python. Now, what is deep copy and shallow copy? See, observe it very carefully. The new list created, my list 2, is pointing to the same memory location, the same value where my list 1 was pointing, right? Now, suppose instead of 12, if this is again a list, instead of 12, there is again an list, nested list inside my list, then how the memory will look? See what I'm talking about. So instead of 12, if I will have one another list, right? With values like A and values like B, values like C. First, let's remove the copy. See, this list index 0 is again pointing to a list because it is a nested list, a list inside another list. So my list variable, my list 1 is pointing to some list, which is again pointing to some values, right? We have seen this scenario. Yeah, create another memory location. Now again, this will be pointing to the same memory and the values are there, right? Now if we use dot copy, see what this will do. So observe it very carefully. The index 0 is pointing to the nested list, right? So what do you think? If I will change the value of this B to something like 3000, that value will be reflected in both lists or not? Just yes or no. If I will change the value of this list, any value like A, B or C, any values will be changed. Just that will be reflect in my list and my list too. Yeah. So that value. So what is the use of copy and why we are using copy? So copy won't work if your any of your list is nested list, right? So for nested list, suppose your child list, your list 1 is containing some nested element, not only nested list, some nested element, right? So the and other elements, suppose it is containing a dictionary. Okay, we will discuss about dictionary in detail, but in this case, let's take example of a dictionary. Then again a list. In this case, instead of shallow copy, we will need a deep copy, right? So how does that deep copy will work? So for that, we have to import a library. We have to take help from some pre-written code. For that, that particular deep copy, that shallow copy, yeah, that deep copy concept, the code for that deep copy is inside our. This copy and this copy are two different things, right? This copy is a function, right? A method defined for list. Okay. But this copy, it is a module, a Python code, right? A Python module. Okay, and deep copy is somewhere written inside this. Yeah, there are deep copy, different methods of deep copy. See, the deep copy is implemented here, right? We are going to use that deep copy. So that's why instead of just importing the whole uh, Python file, I have imported only the particular function, the method we need. Now, while copying to my list too, instead of copy, use deep copy, and this is the particular syntax to use deep copy. Right? There is a difference between the syntax of copy and deep copy. Okay, so take care of that. Now let's try this. This will be a very big value to visualize. So remove these. Just ignore this first variable. So this is something we have created nested list. After this, while performing deep copy C, now the index 3 is not representing or not pointing to a list, to the same list. A new list will be created for that, that will be holding the values. Okay, both are entirely different. Okay, so what shallow copy will do, so I think, okay, again repeat this one. See, if instead of deep copy, if I will perform shallow copy, okay. See, what is the use of shallow copy? So shallow copy will blindly just copy the memory address of the exact values. It will copy the memory address of 1, memory address of 2, memory address of 3, and the memory address of this entire list, right? This nested list, memory address of this nested list to index 3. Okay. But what deep copy will do? See. So what deep copy will do? See, this is the doing of only the copy, shallow copy we have used, right? It copied just the memory address of this list. But what deep copy will do? It will get inside this memory address, create a new list for you, and then copy the values, the address of the values. Okay, so this is the difference between deep copy and particularly we have the copy. Now suppose if there are multi-level nesting. Now what is multi-level nesting? Suppose inside the nested list, again you have another nested list. Inside my list, I have this nested list. And again inside that nested list, I have again some other list with some values, right? So deep copy will again handle this. So if inside this, I will create a value minus 1 and minus 2. See, it will be my list was created. Inside that list, another list was there, and inside that list, again another list was there, right? Now, what that copy will do? Copy will just copy the address of this list to your whatever the my list to you have created. Okay, so that is shallow copy. It won't go inside this list and go inside the values to copy the exact value addresses. No, it will just copy the value in label one. This is the first level of list. This is the second level. This is the third level. Actually, it is a 3D list. So there are three levels of list. Now, what your deep copy will do? See what deep copy have. It is created a new list for you, a new list for exactly each value. A new list were created, and after performing deep copy, your the list three is pointing to exactly the value, not to some list. It is exactly pointing to the values, not to some other list or some other dictionaries. No, it is exactly pointing to values only, right? That is the difference between deep copy and copy. Deep copy will move inside from one list to another inside that list to fetch the exact location of values. Okay, no, it's not waste much time into it. Guys, please try to understand these concepts right, because when we discuss about dictionary, there are some scenarios where we have to go through this again. Okay? Now we have seen copy and deep copy. Just in some other values. So let's first see reverse dot reverse, and after performing dot reverse, as the name suggests, it will reverse the particular list. Okay. Now tell me one thing. If I will print the ID, the memory location of my list before reversing and after reversing, the memory address will be same or different. So the memory address of my list before reversing and after reversing will be same or different. The syntax for this one is your list variable dot reverse. List variable dot append. So what is this dot append? Same. So exactly same. Now why? Because the lists are mutable. So there is no need to create different memories. Right? You can change the values and do operation inside the same memory. See. So this is my current list, right? My list is now this, a reversed value. And dot append will be used to add new value. My list dot append. Suppose I want to append hello, right? Now guys, always take care of that by using append, the value is inserted at the last, at the end, right, of a list, right? So append, then we have pop here reverse sort. So what do you think? What is the role of this pop? What it will do? Yeah. So pop is used to delete exactly the last element. Okay. Now there are two syntax of pop. There are two ways we can use pop. See, if I will pass two inside this pop, okay, so it won't throw me any error, right? So there will be no error. Okay. Now just ignore this one. Just ignore. So there will be no error. Now let me know. Will it delete the value two or the index two? What is the meaning of this pop two? It will delete the value, exactly the value two or the index two. Yeah. So it will delete the exact value. Also, I have given the both the two. Take it as one. It will delete the exact index, not remove the index. Yeah. So it will remove the exact index element, right? So the index, sorry, the element 3 was at index 1. So it will delete that. If you will use it with index. If you will not provide any index, it will delete the last element, right? Now, for here, let's- now sort is used to sort in ascending order, right? So your list will be sorted in ascending order. Okay. Now, okay. So what happen if you want to sort a particular list in descending order, right? How to do that? For that, use use this particular syntax. Okay, it will sort your list in descending order. Okay, and guys, we will discuss about these things in detail. Okay, I think in tomorrow's session we will discuss about these things. Right? What are these keywords? Reverse equal to true. What is this reverse equal to true? We will talk about that. Right now, just focus on the syntax. So it is used to print in reverse order. Right. So if I will append hello, I will print my list. This is the current value of my list, right? Then again, I will sort this my list. And let's append some more values. Right? Let's append some more values. Something like -1, -2, -3. So after sorting, let me give you a okay, so after sorting, what will be the output? What will be the output of this particular list? And please use only pen and paper. Okay. How to edit the list? Okay, so all your answers are wrong. You will get an error. Now, why this error? So, what is sorting? How you can sort a value, right? So, for sorting, how you can know that one is greater than two or -1 is smaller than 10? So, you can compare, right? Using comparison operator, you can compare that 10 is greater than -1. Okay. Now, how you can compare? Suppose take any integer. How you can compare 12 with hello? Can we compare 12 with hello? Is it possible? We can compare a integer value or a numerical value with a string, right? So that's why we are getting an error. The error is cannot use greater than, or you can say comparison operator for a string and an integer data type. There is a string in our list, right? So always take care of the data type or the data your string, your list is storing before using dot sort. If I will remove this, you will get the output. There will be no problem. Yeah. Now it's correct. But if we are inserting the string values, then there will be error, right? Now, if I will insert a float value, suppose I will insert 2.89 and I will insert minus 0.98. Now, will it throw an error or we will get a sorted list to change a value? See, suppose I have a list 1, 2, 3, 4, 5, right? I want to change this 2 to something else, right? First of all, let's access that 2. So the index of that 2 is 1. Now, let's change that to 100. Let's print. See, the value is changed from 2 to 100. So access any memory location and change the value. Instead of 100, I can insert an entire list there. No problem. Right? Any response on that? How to the sort will work or not if we have the float values? Right? So think logically. Is it possible to compare minus 0.98? Mathematically possible to compare 0.98 with 12 or 13, right? So add operation. See, append is the add operation, right? You are asking for a add method or the mathematical add, the plus operation. Append, if you are asking for a method, then append is the add method for method, add operation for list, right? How to find the method? So it is possible, okay, to compare a floating point. So that's why we will get the values. Okay. Now the last one was remaining is we have clear list var dot clear brackets, and it will delete all the values from your list. It is used to empty an list, right? And see, after this we will get an empty list. Nothing is there, everything will be deleted. Okay. Now the max and all those functions. So these are some functions. Yeah. So these are some functions specific to list, right? This copy won't work with your string or integer. This append won't work with your dictionary, right? The other data structures we will see right now, right? And this reverse will not work with your tuple. Okay. So there are some, you can say, general functions which will work with each and every type of data structure, right? I mean iterable data structure. No. See, we have seen deep copy. Deep copy will work with dictionary, tuple, list, all that, right? Now, one keyword is there, iterable. What is an iterable? So consider, for right now, only consider that any data structure which supports indexing is iterable, is known as iterable. Okay, string supports indexing, so string is an iterable. Uh, your list supports indexing, so list is an iterable. Okay, now see, suppose I have just one, and let's take only integer values, right? Again, if you will take a string value, then you cannot add a string and a integer, right? So let's only take integer, or if you want, take float values to print the sum, right? So to print the sum, use sum function. Sum function is used to add up the values of an iterable, right? Okay. Now, if you want the maximum element, you use max function to get the maximum element from your list. If you want the minimum element, use min. Okay. If you want to get the length of your list, right, use len. And this is one of the, you can say, most important function to remember, right? The length function. And let's print these, right? So this is how you will perform summation and all this. Okay, so there is a dedicated function for that. Once how to count by units, same element of. Okay, so let's discuss about those functions. So those are present in your PPT. Okay, so yeah, this index is used to check the particular index of a element, right? So we don't have count here, right? Okay, so let's discuss about that also. So other than these, we have insert, we have index, we have count. Let's here only let's discuss about these. Suppose so what is the use of dot index? So dot index is used to find the index of an element, right? So this is the syntax. Your list variable dot index and the element you want to find, right? And it will return some, it will provide you the index, right? So you will need a value, a variable to store that index, right? What is the use of this syntax? This syntax will give you the index of 1. So you will need a variable to store that index, right? For that, let's use a. If I will print a, see, there are multiple one, right? But it will only provide you the first occurrence. Whenever it will find the first occurrence of the element, it will give you the index of that first occurrence only, right? See, return the index of the first occurrence. Okay, suppose if I will pass 100, so 100 is not there, right? See, we will get an error, not something like minus on one or not found, not that. We will get an exactly error. Okay, okay, I will share the PDF. So let's find three. Okay, suppose we have multiple threes. Suppose we have multiple threes. Okay. So it will only return two. the first index, the first occurrence of 3. Right? Now we have count. And again, so my list, your list variable dot count. And inside this, count the occurrence of one element. Right? Now, what this will do, suppose I want to count the occurrence of 3. What it will do, it will count. After counting, it will give you the answer, right? The result, like that 3 is occurred 2 times or 1 is occurred 4 times. To store that result, again we need a variable, right? So use a variable to get the value. Now let's print b. So the occurrence of 3 is 2 times and the occurrence of 1 is 4 times. Then again, if I will insert some element which is not in our list, we will get the value 0. Clearly observe the change in the behavior, change in the output of two different methods. While using count, to count some value which is not in our list, we will get the value as 0. But while searching for an index, right, searching for an index for an element which is not in our list, like this 300 is not in our list, we will get an error. Any more question, guys? Okay, so let's not invest so much time in only one data type. Let's move to, okay. Now let's move to conditions, right? Conditional statements. So we have conditional statements in Python, or you can say that the technical term for that is flow control, flow control statements. Now we have seen that I've shown you that interpreter will start executing from line number 1 and it will execute each and every line, right? So the interpreter will start from here and it will run each and every line. But suppose I want to control that, which part will be executed and which part will not be executed. I want to control that. So how to do that? Suppose I have a variable 10, right? If that variable, sorry, if that variable is greater than 20, if that variable is greater than 20, print true, else print false, print and right. And one more thing, guys, let's not take 10. Let's take a user input. So how to take a user input in Python? Use input keyword, right? This is used to take user input in Python, right? So if I will execute this code, if I will execute this code stops to take my input, right? So if I will provide 100, I will get an error. Now focus to this error. What this error states: cannot compare a string and an integer. So we are pretty sure that 20 is an integer, right? So what happened to this 100? I have provided an integer, but that is treated as a string. Let's take care of this first. That is treated as a string. If I will print the type of A, so the type of A, I will provide 100. See, the type of A is string. 100 is treated as a string. Okay. So guys, for the submission link, you don't have the submission link, right? So you have to typecast this input to the desired data type you want. I want 100 to be an integer type. See, now it's giving us integer. So we have seen this typecasting, right? So if it's looking a complicated one, you can use something like this. A is equal to int a. Right. Now see one more thing. See, the program stops here to take my input. It is not printing anything like provide the user input or provide an integer value. Right. That will be a pretty formatted like, right? So let's provide a string here and ask the user for an input. Provide integer input. Right. See, now it's asking me for input. Provide integer input. I will provide 100 and it is of class integer, right? Now let's see how this code runs. Okay. See, first it is asking me for an integer value. So I will provide, let's give 100. Okay, so what is 100 greater than 20? It will be true or false. 100 greater than 20, it will be true or false. After giving 100, press enter. What we have? See, the first input of 100 is taken as an string, right? Now we will typecast that to an integer format. Now it is typecasted to integer. Now what is the value of a? That will be 100, right? In place of a was replaced with c. A was replaced with 100. Okay, so 100 is greater than 20. That will be a true value, a true condition, right? If I will ask, what is 100 greater than 20? It is true, right? See, if the condition is true, we will go to line number 5. We will print true. We will never reach line number 6 and line number 7. The interpreter will never go to line number 6 and line number 7 if your condition is true. Okay, and the program ends there. Right? See, now how this if and else condition works. So this is the syntax. If keyword, a condition, okay, and a colon. That condition may evaluate to a false value or a true value. That depends on your condition, right? After that, inside this if, always take care of this space. Actually, it is a tag. It is a, you can say, a good behavior to practice to provide tag. Even if I will only provide a single space, that will work. I will provide only a single space, that will also work. Right? But always provide a tab. Okay? So inside this if, whatever you will write after providing a tab, that will be considered as a true statement. That code will be always executed if the condition evaluates to a true condition, right? So code will be executed if condition is true. Right? Otherwise else, then colon, and then after tab, code will be executed if condition is false. Now let's take multiple lines. False. Yeah. Then again debug this one. Let's see how the code will run right now. So it is asking me for input. I will provide -90. Enter. That -90 is taken as a string. We will typecast that to an integer and it will be typecasted to -90 an integer format. Now tell me, -90 greater than 20. This is a false condition, right? See what interpreter will do. It will never visit line number 10. It will directly jump to line number 11, directly jump to else. See, line number 10 was never visited. It will jump to line number 12. Then it will also execute line number 13. Then end, right? So this is how a condition or flow control works. Now, suppose I have a few questions for you. So take user input and right, print even integer is even, otherwise print odd. Okay, so suppose this is our question. Now, first of all, take a user input, a number. Take user input. So let's take a user input. So generally for taking user input, I don't like this Jupyter notebook very much, right? Because it will pop up somewhere here, the output dialog. Let me see. See, here it is asking me to provide an input. Keep it 12. That's it. The 12 is taken as an input. Now, what was yeah. So even if the integer is even, otherwise print odd. So when an integer is even, how do we know an integer is even? If we will divide an integer with 2 and get the remainder as 0, we will say that integer is even, right? So if, what is our condition? Number is divided by 2 and the remainder is 0. So to take the remainder, we use modulo operator, right? The percentage sign. To take the remainder, we use percentage sign, right? Okay. So just print even, else print odd. Let's run this one. Let's provide 0. 0 is even. Let's provide 12. 12 is even. Let's provide 13, and 13 is odd. I think it's pretty clear how if else works, right? Now, so it is only the matter of understanding, right, how to implement these. Suppose there is a question, take an integer as user input, print if integer is even, and suppose let's take greater than 0. Let's not take yes, let's take even, large events, print large event, right? And let's take greater than 0, let's take greater than 10. Print small even if integer is if integer is smaller then 10. Right? Otherwise, print large odd if greater than 10 or small odd. Okay, so how to achieve this, right? First of all, let's create an integer, take the input, right? First of all, let's check if that particular integer is even or not. If it is even, inside even, again we have to check something, right? Inside even, we have to check that that number is greater than 10 or smaller than 10. So if number is greater than 10, print large even, else print small even, right? Now else. See guys, these tabs, these will describe that this print statement is written inside this parent if or this child if, right? So always take care of the indentation, the number of tabs you will provide. Okay. So this particular example is an example of nested if else. Suppose we will provide 12, it will be a large even. We will provide 9, small odd. If we will provide 2, small even, right? Now we can achieve the same thing using logical operators. Suppose if I will do if num modulo 2 is greater is double equal to 0 and and num is greater than 10, so what we will print large even. Now see, here we are going to use elif. What is elif? Elif is again one more keyword, one more you can say condition, which will be checked if the first condition is false, right? If the first condition is false, it will check the second condition, and num is greater than 10 or equal to 10, then not small even. Now again elif num modulo 2 is not equal to 0. So this is the typical use of your you have else if, right? Let's provide 133, right? So 133 is a large odd. Again, that 133 passes here, and that is again large odd. So this num variable, it is defined for both the cell, both the code. This first code and the second code, right? There is nothing to do with if else, right? This num is available for both this first code and this second code, right? Okay. Now also we have time. Let's discuss about loop. What is loop? Suppose there is a suppose your task. Okay, let's get a task. Right. So suppose this is your task. Okay, so how to achieve this? One example is, let's create a my string variable with name hello, the value hello world, and let's print my string, and we can use multiply. This multiply will repeat hello world 10 times. Right, this multiply will repeat hello world 10 times. Keep a space here. Okay, one more thing we can do, instead of providing it inside this, use 10 here. Right, so what is the meaning of using 10 here? What you can say, what will be the what your string will look like? Your string is only hello world and repeated 10 times, or your string will exactly hold the hello world 10 times, something like this. Hello space hello, how your memory will look like. So let's see. Instead of 10, let's do 3 times. See, this is how your string will look like. It will repeat the variable again and again and store that exact value in the string, right? So it is memory consuming. Okay, so it is memory consuming. How to print that on next line? Use forward slash in your string, right? Inside your string, use forward slash. It will be printed on next line. What is the meaning of this forward slash? Change of line. Now we are looking at the memory. So this is how the memory will look, right? Your memory will create, sorry, stores your string. If I will do suppose 10,000 times or something like this, a very large number, it will take a very large amount of memory to store that value. Okay, a very large amount of memory to store that value. So instead of doing these things, let's repeat the task. What is the task? Printing hello world. Let's repeat this task again and again. Now, how to do that? So for that, we have to discuss two topics: loop, and another one is range. See, if I will print range 0 to 9, this range is a function or method which is used to generate a number from 0 to 9 minus 1. From 0 to 9 minus. Instead of this, can we store it like this? Okay. So what is the use of this range? This range will start from 0 and count up to 8, right? This is the use of range. Range start and will generate number from start, then start plus 1, start plus 2, up to and minus 1. Always take care of this and minus 1, right? If I will start from, instead of 0, I will start from 3, then we will get 3, 4, 5, 6, 7, 8. Right? Now, if I won't provide any number, then in this case, it will by default start from 0, right? So take care of Always remember these two syntax. If we will provide a start and if we will not provide a start. Okay. Yeah, if we will take 10, then it will print from 0 to 10. Okay. Right. Okay. Now loop. So this is a typical syntax of writing a for loop. There are three types of loop in Python for loop. First one we have for loop. Second one we have while loop. Third one we have do while loop. Right. We will only discuss for and while. And suppose we will only discuss about for, we will little only just see the syntax of while. That will be enough. I think. And inside for there is one more version of for that is known as for. Okay. Okay. Now what was our task? We have to print my string, suppose 10 times, right? So how to run a for loop for 10 times? For in range. So if I will take from number 0 to 9, in number from 0 to 9, I have total 10 elements. Sorry, 0 to 10 or 9. From 0 to 10, I will have exactly 10 elements and use print whatever that is. Hello world. See, hello world is printed for 10 times. Now let's discuss about the syntax of for loop. What is the syntax? For variable in keyword range function, right? This is the syntax of a for loop. Now, what is this I? What is the meaning of this I? So, just right now, I think I have used the keyword iterator. Okay. So, what is this I? What this range will do? It will generate number from 0 to 9. What this I will do? First of all, range will generate 0. So, what I will do? It will catch that 0, right? Then range will generate 1. This I will catch that 1. So after generating 1 and catching 1, it will repeat for 2, 3, 4, 5, 6, 7, 8, 9. When range will generate 9, this I will catch 9. After that, range will end, right? There is nothing more to generate. Then your for loop will exit, right? Then your for loop will exit. See, the value of I was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this is how a for loop works in Python. Variable in range will generate some values. That values will be catched by I or whatever variable you have created, right? And just print the perform whatever operations is needed, right? So see, there is no need to print this I because that's not our task. Okay, we only have to print hello world 10 times. One more thing, guys, that it is considered a good practice. If there is no use of a particular range value, use underscore as your variable, right? Because there is no use of this range value other than running a for loop for 10 times. There is no other use for these values 0, 1, 2, 3, 4, 6. There are no use for these values, right? So up till now, guys, any doubts? We will see in detail about for loop and while loop. But other than that, do you have any doubts? Okay. Okay. So if there are no doubts, let's discuss about for each loop. Now there is one more syntax of using for each loop. For variable in iterable. Iterable. Suppose I have a list. Right. There are two ways to print a list. One is this. Another one is by using for loop. For I, not I, let's use good name for element in my list. Print element and with space. These are two ways to print a list. Now, how this is working? Okay, let me show you in the debugger. Okay, guys, focus on this screen. Right? See, I have a variable my list created with some values 1, 2, 3, 4, 5. Right? Okay. Now we will print the values. Now we come to for each loop. See one more thing. This element variable is not defined outside for loop. Right? This element variable only exists inside these two lines, line number 4 and line number 5. Before that, there is no element variable. We have created a my list, but element variable is not created yet. Right? When we execute the for loop, see, we have the element variable, and the first value of your element variable is the first value of your list. Right? Second value is the second value of your list, and see, the flow control is stuck here. It is running again and again. Right? Then it is again running again and again. The last value of element is 5. After printing 5, it will end. Right? And see, we have printed all the values. Let's instead of this, let's take 100. Take this will be enough. See, element is not defined, nothing is there. Right? See, that is not a correct definition. Element variable doesn't work as an iterator. Iterator is something else. Right? There is a, you know, the there is some special work for a iterator. Iterator performs some special operations. Now we have element variable is not defined right now. See, the first value of element variable is the first value of your list, right? Then it will print that 100. See, it will print that 100, print that 100. Now the second value of your element is the second value of your list. Print that and perform this again and again. Okay. Now, guys, why we are doing this? I mean, why there is a need of for loop? We can print it using only the print statement, right? Okay. So suppose there is a, so let's take one task. Our task is our task is take user input in a list. Now, add increment each element of the list by 20. Right? Okay, so what is our task? First of all, let's take a user input in a list. So we cannot take a user input in a list like this. Okay, we cannot take user input in a list like this. Um, let's create an empty list. So there are two ways to create an empty list. I will go with this one. Now we want the user input, right? So up till, suppose how many user inputs we want. Let's first of all let's take an n, take in input, enter the size of list for I for I in range. Let's create a take input in this a, right? So what is this a? This a will be our input which is given by the user, right? This a will be the input which is given by the user. What is our task? We have to insert that input inside our list, right? So for that, use my list dot append a. So this is a way to take input in a list. There are multiple ways. This is one of the way to take input in a list, right? Let me show you how this will work. See, it is asking me for the size of the list. So suppose I want a list of size 10, right? Now let's provide 1, 13, 14, 15, 20, 50, 10, right? So okay, so I'm going to put in this, right? So see, this is our list. A new list is created. Always take care the condition we are typecasting it to integer, right? So please don't provide a string type value. We will get the error, right? We cannot typecast and string to integer. We have seen that. If you want to insert strings, don't use int conversion. Just use string and provide a string, whatever type of string you need. Right? So all of these are our inputs list. Now, so what is the requirement? So we have taken user input in a list. Now, what is the requirement? We have to increment each and every value, right, by 20. So see, now the for loop will come into play. For I in range 0 to length of my list. Now, someone has asked how to change the value of a list, right? We have seen that by using the index, we can change the value of a list. So what we are doing right now, we are adding 20 to each and every element and print the list. In this case, now, see, so what happened in this for loop? What we are trying to do? Suppose if I want to add 20 to index number 0, what I will do? My list index number 0, add 20, and then update the value of index number 20. This is what I will do, right? The same thing will be done by this I. What is the first value of I? That is 0. Second value of I, 1. Third value of I, 2. So we will iterate over each and every element of a list using indexing. This is another way of iterating over a list using indexing, right? Now let's go on size. Let me give the size as 5. The first value will be see, after adding 20 to each value, this is our list. Before adding 20, this is our list, right? Okay guys, so that's it for today. Okay, work with these different types of for loops for each loop, how to work with this indexing for index loop, and if you face any difficulty or any error, we will discuss about that